what a day! What a lovely day!
Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you're new to this channel, or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you'd like to support this channel, there is a super chat. Massive shout out to all who've been super chatting during the break. There's also a PayPal link in the info box below the video once it's rendered. But most importantly, if you'd like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel. So please share the show. And one last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now we are joined by Tommy, Sleeping Warrior, Ranty Flat Earth, Planar Walk, P Mars, Music, I don't know your surname, or screen name, surname, Jose, Glee, and Effie call Mike.
Don't worry, Nathan, I'll be logging in with my primary name. This is my channel email. I don't have a channel on my...
Has somebody got their watch page open?
Sorry about that. People around me today.
No worries. Well, good to have you all.
Thank you.
Can I present my second argument here?
Sorry, who was that?
Yes. Tommy. I don't. Is it Nathan? Is it?
Yes.
Right, Nathan. How you doing, mate? All right. No, North Pole, right, on a flat Earth. So you believe the Earth's flat? Is that right? Can you hear me? Hello.
Yeah, we hear you. I'm waiting for you to actually make a coherent argument. You don't have to pause and get affirmation for every sentence.
Okay, cool. Right. So, say me and you went to the North Pole, and we put our backs to the North Pole, yeah? And we both walked 10 steps ahead of us, and the North Pole is behind us. Which one of us are facing south?
Is this on a ball or on a flat plane?
Exactly. But if we're on a flat plane, we both got our backs pointed towards north. Who's facing south?
Sorry, what's the point of your example? Hold on. What's your point of your example?
I'm just wondering what you think on that.
I've never been to the North Pole. Neither of you.
Okay, but if it's a flat map, then the North Pole is going to be in the centre, is it not?
Sorry, I'll just repeat it. I have never been to the North Pole, and neither have you.
Okay, we don't need to go to the North Pole.
More of a thought experiment.
It was one of a thought experiment, which he doesn't want to participate in. Let's say I'm in Birmingham, yeah, England, and you've got somebody who's, I don't know, in America, and you get a compass and we both look north. And south would be directly the opposite direction to where we both, but we're different parts of the Earth. So therefore, we'd be facing in different directions for south. How would you explain that on a flat map?
What are you talking about?
It's the same. It's the same answer on both maps. I don't see why there's an issue between the two.
How can south? It can't be the same because on a flat map, south would be in completely different directions. Whereas,
but it would be the same on a sphere as well.
No, on a sphere, because the sphere connects to each other at the bottom. On a ball, it would go. They'd point down to the same direction. But
you said that if we were stood at the North Pole, did you not?
You didn't want to. You didn't want to participate in the North Pole. Say, like, if you've got a table, right, and you've got the North Pole's going to be in the centre, and England and all the different continents are all around, don't they? So if we're all facing north from different angles, then south would have to be in completely different directions. South
right, answer this question. Are we stood at the North Pole or the South Pole?
We could be standing anywhere on the map.
Right, so let's stand at the North Pole on a globe.
Yeah, we're at the North Pole.
You said if you got your back towards my back and we're at the North Pole, you're going to be looking south and I'm going to be looking south. Correct?
Yeah, but that will all lead to the same point because the globe brings it all together.
Prove that point.
Well, if you're on a ball, you're at the top of a ball. Imagine a football.
Yeah, I understand the concept, but I want you to prove that if you do the same thing, what you've just said, if you head south, you will then head to the same point. Prove that point. Is there any evidence that proves that if you go from the North Pole down to the south on any bearing from North Pole, that you get to the same place?
I don't think you're quite. I think you're straw man in the argument here.
No, I'm not. I'm challenging you on your assertion that you said.
God.
That
Sorry, Anthony, hold on, guys. Hold on. So he's literally clarified your position and then asked you to present evidence for your position, and you have accused him of straw manning your argument. He's literally clarified it back and then said, have you got evidence for it? Why are you sighing? Acknowledge what I've just said. Rather than actually address the fact you have no evidence to back your assertion, you have accused him of using a straw man argument. Now, number one, you don't know what a straw man argument is. That's
pretty. Straw man argument. It's basically when somebody like makes a small, gets your argument. Shut
up. Rather than address the fact that you don't, I'll just keep doing this and pointing out that you're rude. Shut up.
I'm rude.
Shut your mouth. So, don't need to give me permission, right? Shut your mouth and I will demolish what you have asserted. He has pointed out you have no evidence for your assertion. Rather than say you're...
And then you're not...
Shut your stupid mouth!
Are you going to answer the question?
Are you completely triggered by us humiliating you again for a second time?
You simply won't answer it. You won't participate.
Yeah.
Can I clarify Tommy's point and also provide sort of an explanation that I know that flat earthers are likely to give? So I think the point that Tommy was trying to make is if two people are at the North Pole, right, and walk 10 steps in opposite directions, his point, I believe, is which person is pointing towards the South Pole. Now, I know that a lot of flat earthers...
Sorry, that's where your logical fallacy comes in. So if we're on a sphere and we walk 10 paces on a sphere, so you have already begged the question that we're on a sphere with that example. That's begging the question. It's the very definition of begging the question. Do you understand what begging the question is?
I do. Now, what I'm...
No. Stop. You understand what begging the question is. So you have said, if we are on a sphere, so you are presupposing your outcome in your example.
I think I may have represented it a little bit in a wrong way. So if we're on just say we're on a flat Earth, right? This is what Tommy's I believe this is what Tommy's trying to say. If we're on a flat Earth and we are at the North Pole and we walk 10 paces in either direction, what Tommy is wanting to know is which person is facing towards the South Pole. Now, I know that a lot of flat Earthers don't believe that a South Pole exists. And I think that's the answer.
Okay, no problem. So you're going to now insert a straw man. You think we think. Oi, Tommy, this is what a straw man actually is. This guy has just represented what he believes we think so he can demolish it. That's called a straw man, Tommy. Retard. Okay, now let's just point out that's a straw man. And the way it's a straw man is I already said, I've not been to the North Pole.
But the real question here, and I'll allow you to answer this yourself.
No, you haven't acknowledged what I've just said. You're just moving on. Do you understand that you have presented us with a straw man?
Yes, and that's
Do you understand? Shut up! Do you understand that you have begged the question and assumed you're on a sphere?
Well, the thing is...
Do you understand it or not? Do you understand that you have begged the question? Another formal logical fallacy? Do you understand it or not?
I do understand that.
Excellent. One more thing. Do you understand when I say we have not been to the North Pole, that we have not been to the North Pole to test what you're about to claim?
I understand that, but this is more...
Excellent. So you've got nothing more to say in your thought experiment. I'm not interested in thought experiments. I'm only interested in what you can prove in reality.
But I do understand that. But I think what Tommy was doing is he was presenting a thought experiment, just trying to sort of work...
Sorry, are you going to summarise what I've just said and demolished?
Well, I actually have tried to explain this. I'm not trying to set up a straw man for you. I'm just...
You said, I think that you think if we're on a flat plane, this will happen. That's called a straw man. I already got you to concede this. Are you now going back on the fact that you did, in fact, present a straw man argument?
Calm down, mate. Just
right, you're going to get kicked out. one more time with you retard telling me to calm down here, I am taking your shit argument to pieces painstakingly while you smile. You, my friend, are a retard, and I'm going to point it out again and again and again. You can smile like a total dingbat, yeah? You're just looking foolish. Smile it off, mate. You're just looking like a retard who doesn't understand what R is.
I understand what you're attacking
Shut
me. Shut
your mouth, dickhead. Right, would you like to carry on strawmanning us?
I was actually trying to present a reason for you all, was because I think Tommy's argument is a bad argument. I do agree that it's a bad argument. I understand that flat earthers would have explanations for this. I was just trying to explain it to you and also explain to Tommy at the same time why it's a bad argument, because flat earthers can say that they don't believe that a South Pole exists, and that is a valid argument.
Sorry, who has said that? Yet another straw man representation with the same exact straw man? Are you joking?
Okay.
Are you joking? Are you seriously going to piss this straw man in my face?
Okay. Well, then...
I asked a question. Are you going to continue to piss this straw man in our faces?
Well, I'll let you answer. Do you believe that a South Pole exists?
I haven't been. I can't quite believe my ears. Listen up, dickhead. I've not been.
Okay, so you're agnostic on that.
Excuse me, I've not been. Not agnostic, I've not been. I don't know. I've not been, neither of you. Have you been to the South Pole?
No, I haven't.
So you're not speaking from experience. So this example will definitely not be from experience. What about the North Pole? You been there?
No, I haven't been to the North
Well,
Pole.
why don't you shut your mouth about the North and South Pole and what they might do in a thought experiment?
I think you're misunderstanding the...
No, I'm not misunderstanding. You're not listening. I've not been there. You've not been there. You haven't got the vaguest idea what happens. So let's not talk about this.
Okay, fair enough.
Yeah, it is fair enough.
Now.
Right. Now, if it's possible, now it's taken a show and a half because of this grinning muppet here, Tommy. We'll get back to...
Good way to avoid the question, though.
What question? What have we avoided? What's R? Have you avoided my question? What's R?
I've admitted I don't know, mate. You know.
Right, well, go and find out what it is. Don't tell me I'm avoiding questions. Your concession that you don't know hasn't in any way mean you've gone forward and tried to correct your ignorance, something you're accusing me of, you complete grinning muppet.
Because I'm grinning, you shouldn't be getting upset because I'm grinning. I'm grinning because I'm just trying to have a conversation about something, and instead of attacking me and getting all personal and getting all irate towards me. No, you're not letting the actual debate and the points I'm trying to make.
If I can just interject a little bit,
breathe and have them to reach. If you want a fair discussion, then also give me a fair room to put what I'm saying down instead of just trying to make me look like an idiot, me just trying to brandish me with all these names. I'm actually just a normal person like anybody else, and I've just got a few questions I want to ask you, and I'm asking you a simple question. I know you haven't been to the North Pole. But like a thought experiment, like I said, like the other gentleman tried to explain it in a better way.
Shut up. Don't want to hear any more about it. I've already taken this to pieces twice, 3 times, 4 times, and you just want to keep doing it, giving me a thought experiment. Shut your mouth. You've got nothing more to offer. We've demolished your argument. Now I want to get back onto the lying globeheads who do understand these arguments, can get around using straw man arguments, and do assert that the Earth is a sphere while simultaneously lying through their back teeth about it because they know the adverse is the case. They know the Earth is flat in most instances, so we know they're lying. They wouldn't understand these arguments intrinsically. Now these are the people that a show ago, when you came in with your crap argument that you didn't understand and your that you didn't know what it was, this is the point that you told us, oh, well, I don't think it's important to discuss these issues because I want to argue from complete ignorance about this crappy mountain. So now we've dispensed with that, we can move back onto the lying sacks of shit that do understand the arguments, the ones that need to be fed with microphones that crackle and interfere with themselves and expose them as being liars. That's what I'd rather talk about. That's where we started before all this bullshit with mountains that you say look the same when you slide a slider across and they've clearly got an angular size reduction that you want to say, no, it's not really, it's the same. Yeah, these buffoonery arguments that we get here.
The only downside, though, Nathan, is that he'll go away claiming the victim card.
Do what you like. I'll call you a retard because you are a retard.
I'm quite comfortable with who I am and what I'm about. So whatever name you call me, it's like water off a duck's back. To be honest with you, you know.
All right. What about this, Nathan? If he asks me the question that he was going to ask you, can I answer it for him and just like have the hypothetical with him, or should we just?
Why are we having thought experiments? I'm here to find. Hold on. I'm here to find out the truth about where we live and why we've been lied about it. I know for a fact it enters sphere, and every argument that ever gets put forth here will require that R value. Tommy here doesn't know what it is because he's completely ignorant of this argument. He just believes it on blind faith. So am I happy to have a thought experiment argument? No! The guy doesn't even know what the R value is. He's literally a retard.
Okay, I'm a retard.
Yeah, we
so
know.
hang on.
We
So
know.
you
I've
mean
pointed it out. It's not an
literally-
ad hominem. It's not an ad hominem attack. We've demonstrated your retardation in
I'm
cognition.
happy that you've done that. Like, but why are you still going on about it? Just let
Because
that
you
go.
keep interrupting.
I'm a retard, but
I've
a
said
retard
twice.
Like me has just
I've
a
said
simple question
twice.
to ask, and
You asked a question. Why do I keep going on about it? The reason I keep going on about it is the point you came in with your mathematical proof of a globe and distracted from the fact that the people who are continually asserting this with ignorance not on their side, they understand the arguments. Those people are lying through their back teeth and being fed with microphones and people in the background, coaching them while they have their debates. Now, we're in search of truth. That's all we're interested in. If we get it... Oh, you're not interested in giving me more than 2.5 minutes to talk. Yeah, you're triggered. You want to talk. You want to what? Present that you're believing this shit? I don't care what you believe. We're interested in the truth. The people we argue with aren't. You are an example of somebody who's only interested in blind faith, trusting what you read. They aren't interested in blind faith. They're interested in outright deception, lies, deceit, conspiring to deceive, conspiring to smear Anthony here on the panel because they've lied, and they are the people who defend the globe. That's what we were talking about when you came in with your misunderstandings about mathematics.
Yeah, fair enough. Fair enough. But you know, if you don't want to participate in the thought experiment, that's fine. But if anyone else would like to, then I'll be interested to find out why that is.
Oh, really? Sod off to the thought experiment channel.
I tell you, the place for you. The place for you would be the non sequitur show. That's where you'll get the best behavior because that's where you'll be like.
Oh,
That's
you've
where
been
you
loved
can-
there.
Yeah,
You've
that's
been
where
loved there.
the non sequitur show is where you can deal with these non sequiturs. So piss off to the non sequitur show with your non sequitur argument. That's where they deal with this shit.
Well, obviously you don't want to deal with it like by just be having a
Deal
civil
with what?
conversation and talking about it.
Deal with what?
You're not open
Your
to-
thought
you're-
experiment. This is reality we're talking about. You complete idiot. We're interested in what you can prove, your evidence, not your sodding
Man,
thought
look,
experiment.
If it's flat, if the world is flat like you presume it to be,
It is.
then the North Pole is going to be all in the centre, okay? We're all going to be facing north.
Oh
And
my
if-
god, he's literally going to piss this straw man into our face again. If it's not the other guy pissing this straw man into our face, it's this idiot. It doesn't matter how many times we say we've not been there and haven't got the slightest notion what happens there. It doesn't matter how many times we say it, he just keeps pissing it right back in our face.
You should look at the azimuth to equidistant map. That shows him the angles perfectly, how it works perfectly on that circle.
Yeah, we could show it him, but essentially he needs to figure this out for himself. He needs to go and watch a video that shows it. He obviously hasn't, and we're not here to babysit him and suck his thumb for him.
Flat Earth 101.
I mean, one of the questions that I have about, particularly about flat Earth, is why light would, because I understand light well enough on a globe, well, in a globe model to understand how it works, right? But in a flat Earth model, to me, it would have to have different things that it would do. So it would have to work in a way so as to make things disappear from the bottom up. And I can't remember who it was, but someone started with an explanation saying that it would
Aries diffraction.
Oh, someone said compression. I
Yeah,
can't remember who.
compression. That's right.
Angular side.
Yeah. Because I can understand a little bit of compression because you do get compression from atmospheric refraction. I think.
Sorry, atmospheric refraction. That does not apply to your globe model. When you beg the question, assume R and put people on a globe. So you don't do atmospheric refraction. You do terrestrial refraction. And terrestrial refraction is an arbitrary 7.6R. That's the refraction you claim. So if you want to discuss actual refraction, it makes no sense because it's not applied in your begging the question, proof of nothing, perspective hijacking model.
Well, what do you mean? Like,
I'll say it
trying to
again.
understand
No
your
problem.
argument.
What do I mean? I mean that atmospheric refraction is not what you apply. I'll say it nice and slowly. You apply terrestrial refraction, an arbitrary 7.6R. Remember that R value we were talking about, Tommy? Well, now we're talking about something a bit more complicated. 7.6R. Terrestrial refraction. The thing that is applied to your begging the question, proof of nothing, perspective hijacking globe model. Was that slow enough?
Yeah, it was definitely.
Okay,
So, even a retard like me could understand it.
So from what I can tell, I googled terrestrial refraction, and it seems to be a part. It seems to be a part of atmospheric refraction.
Really? It's just 7.6R, my friend. Just 7.6R.
Yeah, that's what it is.
And okay, so R is to do with the radius of Earth. I know that.
Let's just remember, though, remind ourselves that that's the R that we have the issue with. You know, the radius bit. We assert that we can't prove that there's a radius.
The bit that's not in any way scientifically valid or measured. That bit. The bit that you're trying to prove. The bit that you're trying to prove is going to be applied. It seems a bit strange that you'd apply 7.6R to something that's unproven. That would be, what's the phrase I gave you to look up earlier that you said you understood? Oh, that would be it. Begging the question.
Yep. So
you're going to ignore me completely. So we're begging the question, we're going to assume the Earth has a radius, and we're going to apply 7.6R. 7.6 of that radius that we're presupposing as our terrestrial refraction in your globe model. Okay? So when we're begging the question, because we're using a globe now, obviously we're already on a globe when we're trying to prove it, right? Yeah? Begging the question.
Yep. Yeah, I understand that. When it comes to refraction, not refraction, when it comes to R, though, if we assume that we're on a globe, and I understand that as begging the question, then we can use R because we know that there are ways to work out what the radius of Earth is if we are on a globe.
Sorry, so what you're saying is, if we're on a globe, then we can prove we're on a globe because we're on a globe. Yeah, this is like the most circular begging the question nonsense I've ever heard. So you're justifying begging the question because you can beg the question if you beg the question. That's what you're saying. No, you don't get to beg the question here. Excuse me. You don't get to beg the question here because begging the question is assuming your outcome. The very thing you're trying to prove, you are asking us to assume in the first instance. No. You don't get to beg the question here.
So here's what I'm trying to say. If we are on a globe, right? And
no, that's begging the question. So immediately you're going to piss this fucking... This is a logical fallacy. I've told it you twice, and literally, as soon as I finish the sentence, you say the words, if we're on a globe.
Can you let me finish?
You're going to beg the question. I've just told you don't get to beg the question here, and the next words out of your lips are if we're on a sphere.
What I'm trying to say is that when it comes to because the only way I can really explain this is that if we're on if we assume we're on a globe.
No! How many times? The only way you can prove you're on a globe is by automatically assuming that you're on a globe. And I'm saying no. I realise that every single globe proof relies on you presupposing you're on a globe.
Okay, but you need to assume whether you're on a globe or a flat plane, one or the other. So we have to assume both, and then go from there and get to, the best outcome out of the two.
No, you absolute retard. Yet another demonstration of the total stupidity that is Tommy. No, you don't have to assume anything, you complete idiot.
You see that image that I sent to you in the break? The compression of the boats.
Where is that?
You should have a link to it in the side.
I don't see any links in the side. Only the link that I...
3.png. You can't see that in the side?
No, I can't.
Okay, no worries. Ranty, this you're saying you don't understand compression. You showed us a mountain. Do you understand that the mountain on the left side of the image that you showed us was bigger than the mountain on the right side? I.e. the one on the right was, quote, unquote, compressed?
Yeah. I was kind of hoping we could go back to that.
Let's just see if he says yes or no. Or if he says yes and then pisses it back in our faces afterwards that it's not compressed even though it's half the size.
So obviously the one on the right is at a further distance, but what they've taken it down...
Hey, no, not at all. Oh, you're talking about the boat, or you're talking about the mountain?
The
both
mountain.
Equally,
both
the same.
So the one on the right has been brought up to be the same size using the landmarks that you see on the one on the left to match it to the size, match the one on the right to be the same size, roughly. If just trying to work out how to explain this last part.
You're talking about a blink test.
A blink test?
A blink test would be where you would change the opacity of one as you overlay it on the other, and then you would flick back over it, and you should match up.
Yep, that's what I'm.
Instead of doing the slider, you're doing this blink that you would like to do. I would like to do a blink test on it because I feel that the one on the left is too big. I think you're probably at least 15% too big. It doesn't make a huge difference, but I do see that it is not proportionate.
Well, what I see is I actually feel like the one on the right is. Actually, no. Yeah, you're right. The one on the left does seem it actually seems a bit too far to the left. The one on the left.
It is as well. It's not quite parallaxed correctly. I've noticed.
Yeah, it's not.
Too.
Yeah, it's not centered.
And one last thing, the mirroring that's clearly going on at the bottom. You can see the sky being mirrored in the water, which proves that is just entire blockage. Everything that's the blue and underneath to the skyline at the bottom of the repeat of the sky is blockage. It's atmospheric blockage.
Sorry, can someone bring this picture up? It's not displayed on anybody's screen.
I can do this.
And the reason we know that is because of the amount of thousands of images and videos that not only myself has produced, but other people that have showed this same effect where the sky is miraged on the watered mirror layer. And that's what it is. It's a watered mirror layer. It's called blockages.
I do understand that. Yeah.
You do understand it?
Yeah, I do understand.
If you scroll a bit down, you can see that the pixels are the same size as well as the mountain. If you scroll a bit further down.
Oh yeah, they've got this thing down here where they've overlaid it.
There's kind of evidence.
So you've got a few things going on. That's a near image, so that's obviously quite near. It's not suffering any kind of compression, so you're seeing the entire mountain as you would expect.
Yep.
From a much further distance, that bottom part, the part that's already suffering the mirage or the atmospheric blocking that's repeating the sky above, you're also getting the compression there as well, which I showed you the boats in the side chat. I sent you an image, 3.png. You can see that clearly. That's what happens when you narrow your angle. It's, in my opinion, what you've showed doesn't prove the ball at all. In fact, it proves more than anything exactly what we've been trying to show for the past year, that you do get compression at distance. The narrowing of the angle will compress images, and you do see a watered mirror layer that reflects the sky above it, causing blockage.
It's called Aries diffraction. So the video I covered this in was called Flat Earth QED, Good Times for All. So Zachary Sabala basically made a full presentation on how the angular size at distance will cause things to disappear bottom up. So if I give a brief example, if you had a guy standing at, I don't know, 10 miles away next to one of these turbines that Ranty's got hundreds of images of, and he's got a pair of shoes, a pair of boots, and he just leaves the boots next to the turbine, and then you back away from that camera, back away from that position with your camera, eventually you'll reach the point where those boots are only 1 pixel, or represented as 1 pixel in the camera, and then when you back away a bit further, they vanish completely because they have reduced in angular size. Now that's not to say that That's not to say that even though the shoes have disappeared, that you can't still see the turbine with a wider viewing angle above the shoes. So the shoes have vanished, as has 1 foot of the turbine, but you can still see the rest of it because you've got a wider viewing angle to it. And that gets progressively bigger as you get further back. So it starts off with just the shoes disappearing, and you get a bit further back, and then what would have been if there was a guy standing in, his legs would go as well, because they've reduced in angular size also. So they've gone down to 1 pixel, then no pixels. And as you get further and further away, stuff vanishes from the bottom up. It's Aries diffraction. It's the angular size limitation at distance, otherwise known as perspective.
And that's without any atmospherics that's going on as well. So when you confound that with the atmospheric conditions that go on, this mirroring, the blockage, the watered mirror layer, all that stuff, it confounds the diffraction that's going on. So, hello, you know, I mean, we're understanding this. We're understanding how they were able to essentially keep this secret for so long and get away with it. Because when you look at it, quite often you'll see an image and you'll think, okay, right, you know, it can be considered as curvature. It's until you start understanding what's actually going on. And this is what...
No. Sorry, I've got to interrupt you, Ranty. Sorry. Not considered curvature, considered obstruction, which is then called curvature. Even though we're not seeing anything curving, we're seeing stuff being obscured from bottom up, which is absolutely accountable with an angular size reduction at distance to account for the obstruction, not curvature. We're not seeing... Nobody's showing us curve.
So I just want to ask, why is it that when these things are hidden from view, you can then raise your height to bring these things, or if just say you try to zoom in onto something, right, and it's out of view, and then you go higher and then zoom into it, and then it's back into view.
Because you're changing your angle.
You're giving yourself a wider viewing angle.
Over the hill.
You've got a wider viewing angle.
Both can be explained, can't they? You know, perspective explains it on a flat map, and it also explained that it's curvature on a round.
No.
So, you know, but what's more likely, I just think it would be better to describe to the fact that it's being obscured by the curvature of the Earth.
Well,
it's
no.
More
Hold on. Let me just address that,
Ranty.
No. When you account for the curvature of the Earth blocking it, you ignore perspective and you ignore viewing angle. So, no, it doesn't adequately explain it on a ball because you have got the effects of perspective and you don't have the effects of anything being curving away from you. What you do have is just perspective, which is completely ignored in your begging the question proof of nothing perspective hijacking curve model.
Can I make an observation, and specifically to the Globers? You are aware that the smaller mountain has been cropped and then shrunk down and zoomed in. So if you look at the original pictures above the slicing, you'll see that there is a complete size change.
But like I said earlier, you know, you show a flat earther evidence, and they'll call it perspective, and it's just the same sort of like religious stuff that you're accusing globals of having. It's a very neutral argument, which is why.
Right, hang on. Why are we not making progress here?
Because this guy's a religious zealot. I've already pointed that out to the audience. So it doesn't matter how we point out that his model doesn't include perspective. He thinks it does, and has just asserted that they're basically the same. You can account for it with both, and we say no. You exclude perspective when you beg the question, assume R, and say we're on a globe to begin with.
Right. Can you share my screen, Nathan, please?
Yeah, sure.
Well, hang on. So basically, if we can get we can move forward if we deal with perspective. So the question that needs asking is, how big should that mountain look when it's 130 miles away? Do you have an answer to that question?
That's a good question.
And before we get to that, though, can you just look at my screen? I just want, just because it's this point that I've got ready right now.
You're on.
It's right. Okay. So these lampposts, we're looking at a mile stretch here of lampposts. Now, over a mile, we've got 8 inches of curve, apparently, in your model. But here we have the lamppost on the right, which is nearest to us, which looks the full length of the image. And when we get to the one that's a mile away, it looks about a third the size of the one nearest to us. And these lampposts are essentially, what, 50 foot high? So in this example, we're losing 30-odd feet of height, right? But only over 8 inches of curvature, although it looks as if it's much smaller, and you would claim that could be going over the curve of the Earth. This is what we say when we're saying that you omit perspective in your model.
So let's give the lampposts an arbitrary height of, just say, an easy round number, 100 foot. We know they're not, but let's just say they're 100 foot. The one that's in the closest foot in the foreground to us is 100 foot, but so is the one that's furthest away, right? We can all agree that they're all 100 foot. But one of them measures, say, 15 centimeters on the screen, whereas the other one only measures, what, 9? So the question that we need to answer is, how tall should a 14,000 foot mountain look from 130 miles away in feet? Not in degrees, in feet.
It's the same. The actual size is where they've hijacked perspective. So they'll say that regardless of the distance, it's always going to be this number of feet and inches. Well, no,
I'm not asking it on their model. I'm asking it in real world. How tall, how big should that mountain appear to the observer from 130 miles away? So in other words, it's 14,000 feet tall, right? And that's when your nose is touching it, when it's right in front of you. But how small, it's not, I know it's actually 14,000 feet tall at 130 miles, but how is it seen from the perspective of the observer? Because it's not 14,000 feet anymore. It's a lot smaller. It's probably 25 pixels or something like that on the horizon, whatever size it is.
Yes, it is. Why are you asserting this? It's always going to be the same actual size in feet and inches. But we're not dealing with feet and inches when we back away from something. We're dealing with angular size, which is something that's ignored. So by phrasing it, how many feet and inches is it when we back away from it? Well, it's exactly the same number of feet and inches, Anthony, but the angular size of it's massively reduced. And that's what we should be doing, looking at the angular size, not the actual size.
But have we got to the curve calcs, or are we not there yet? We're not there yet.
I'm not making any assertions about anything to do with curvature. These guys so far have been demolished.
All right, well, if we haven't got to the curve calcs, it doesn't matter. But the question that I'm asking is, how big should that mountain be from 130 miles away?
Good point. That's a good point.
What I would be curious to see is what that mountain would look like if you took a time lapse for 8 hours and took the same shot with an infrared camera.
I mean, that mountain should be really small. I mean, for perspective of shrinking it.
Can I just ask a question to the globe defenders here?
Go ahead.
Sure.
Maybe.
How do you think it is that a plane can fly straight and level for thousands of miles on a globe?
It's the gyroscope, isn't it? It like levels out the plane as it goes over, and just because it's such a gradual distance that it covers. That it's like
the gyroscope measures the orientation of the aircraft. It doesn't level out the plane.
So as it's a long distance it's covering, it's going to be such a gradual change that you wouldn't notice it.
So one of the jobs that pilots have is to keep the plane sort of, I think the thing is perpendicular to the Earth, right? Or parallel. Trying to work parallel to the Earth, right? And so
what would that mean on a sphere to be parallel to it? How can you be parallel to the surface of a sphere?
Well, if you take a cross section of the sphere, just say a mile, and use sea level as the mile. So if there's a mountain, we don't count that. If we just count the sea level, right?
Yeah.
And the average height of that, and then we say okay, we have to be because I was traveling in a plane the other day and we're 33,000 feet high, and that's about 10 kilometers. And so essentially, the job of the pilot is to keep the plane at around 33,000 feet. And whilst I was looking at the 33,000 feet, it would go up and down constantly, right? It would go between 33 or 32,997, and it would go up to 33,003 feet. So the pilot has to adjust to keep it, to keep the plane 90 degrees to the Earth. And if we take the, I'm just trying to explain this in a good way. So the plane has to be parallel to, just say, a 1 mile cross section, and we take the average height of that, right? And that's what we can say the plane is parallel to.
Okay, can you say dipping the nose of the plane down?
Okay, so
But how can you fly straight? It flies straight and level for, say, the entire duration of a 12-hour flight, right? Like if you bring a level, you should try this. Bring a level on a plane, and the level will remain level after takeoff and before landing for the duration of the, the vast majority of covering the distance. The level will remain level. So how is
that? You can get Diopter app on your phone. You can fly across the states, east to west or west to east, whichever, and you can take your measurement of your tilt whilst you're on the runway at one side. Turn your phone off, turn it back on again when you land the other side, then do your tilt measurement again, and it'll be identical. Yet you're supposed to have flown around between 11 and 14 degrees or whatever it is on the circumference. Why is that?
Well, the reason that is very simple. It's because the gravity is pointing. When you're in,
but the gravity,
it
only has accelerometers. It doesn't have gravity affected sensors in it. It's an accelerometer.
But also the so-called gravity is going to act on the center of gravity of the plane, not on the nose, right?
True.
So it's not going to. Gravity isn't going to make some kind of natural adjustment in the pitch of the aircraft.
But the pilots do have to make adjustments. And when I was, on the
no. Okay, so what's the evidence that the planes have to make that the pilots have to make some kind of adjustment for the curvature?
No, they don't. They don't have to keep dipping it down. So that's a fallacy.
Well, the thing is, when I was on the plane, I saw it. It was constantly going between some value between 32,997 feet and 33,003 feet, somewhere in between that value.
Thermals.
What?
You have wind up there. You have thermals that would just slightly lift the plane and down and push the plane down. It gets pushed around a little bit. The plane itself, the controller isn't actually pulling the nose down.
Well, and there's probably also some sort of maybe error in the like some kind of small range of error in the measurement, right?
It just keeps the plane at the same altitude, and that's it. And because it's such a gradual change, it's not unnoticeable. You'd have to go at really, really, really high speed in order to notice a shift.
Well, you would. Okay, okay. I'm gonna ask you this then. Do you think that if the Earth were flat, how would it differ? How would the
there wouldn't be much change, no, because because of the sheer size of the Earth, it does appear to be flat, and it does seem flat. So
what you're saying is that a plane flying around a sphere would be no different than a plane flying across a flat plane. To a
degree, yeah, to a degree.
Well, that's pretty absurd. That's a pretty absurd argument.
Totally absurd.
Well, the thing, it basically seems flat because of the sheer size of it.
But your model has a curve. Your model has a mathematical curve we can work out.
Hold on, Ranty. You're saying that there's a... Sorry, did you cite someone? I couldn't quite make out what you said. Did somebody did it? Tommy?
Hello?
You said somebody did it. I just didn't quite hear what you said.
I was just saying, due to the sheer size of the Earth, as you're flying over it, it would be pretty much similar to flying over a flat plane.
No. Don't be ridiculous. You're flying around a ball, and the ball's not that big.
The ball is absolutely massive. Like,
No, it's not.
It is.
No, it's
like-
not.
dude.
It's really
No.
small.
Okay. Do you know that 250 miles away, if you're 40,000 feet in an aircraft, the distant horizon would be 80,000 feet. The ground at the distant horizon, 250 miles away, would be an additional 40,000 feet beneath the plane. So if if it flies level with the horizon, the way that planes actually fly in practice, how could it not be tilted slightly inclined downward in order to arrive and still be level with that horizon 250 miles away? And that's not, and it's only going to take, a half an hour or less.
30 minutes, yeah.
I think the degree is right at like way above plane level. Is like only like a very small amount of the curvature.
It doesn't matter degrees. Where it seems like a small amount of degrees, but it's actually 40,000 feet across 250 miles.
And you do realise we've had pilots on flat Earth debates, not here, but on different debates, and maybe here actually at some point, explaining that they've been a commercial airline pilot for years and they've never ever seen the curve or had to account for curvature or were trained to do curvature even in the simulations. Nothing.
Here's the thing.
I mean, one of my mates is a pilot, and I'm going to brainstorm him a few questions about it. But I think I did brush over the topic ages ago when I used to talk to him a lot. And when he said something about the gyroscope, apparently that adjusts the plane. It's so sensitive, such a sensitive tool, and as it's going over the distance, it's slightly adjusts, but it's undetectable really because it's that gradual.
The gyroscope doesn't adjust the gyroscope does not do anything to adjust the pitch of the plane. It just measures the pitch of the plane.
Okay.
So what?
From where it started, they set a nut at what latitude you're going to be at, and then that is the rigidity that it gives the gyro.
Yeah, this guy keeps asserting that the do you think that the gyroscope is having some effect on the pitch of the plane?
No, I'm just talking about my mate who's a pilot, and it's one of the things that he said. So it's just going off of what he said.
That's obviously a lovely story.
Yeah, and it's a lovely story, but I mean, none of us are pilots here, and we're all speculating on.
Yeah, so you're appealing to authority, but with no evidence to prove what he said was true, right? Or that he said it in the first place.
No, I'm not speculating. I know how a gyroscope works. A gyroscope is on an aircraft is a measuring tool. It's not a machine for adjusting the pitch of the plane.
Absolutely, Nummy's correct. So, Tommy, you've asserted twice that the plane adjusts or the gyro adjusts the plane. It doesn't.
Okay.
I'd say that the pilots adjust the plane based on the gyroscope. That's what I'd think.
They don't. They do it based on the altimeter.
That's the problem. They don't exactly.
Yeah, I think
so. I suggest you can just read a flight manual and find this out for yourself. You can talk to your pilot friend, but read 5 different flight manuals and see what it says.
And that's not even considering the spin of the Earth going east or going west. That's out of the conversation completely.
Yeah. I was just trying to, bring up an entirely separate point. From the photography argument, which is a bit more murky. This is a much more.
It's a bit like jumping on a train. When you jump on a train, you don't go flying to the back, do you?
Yeah, but why is that though?
It's closed system.
Because you're in a closed system.
Right, and are we in a closed system?
It works as a closed system, yeah.
Are we in a closed system?
Due to gravity, and then we're going to start going over that one.
Sorry, the question is: are we in a closed system?
And then we're going to go about the pressure at the space. I know where
are we in a closed system? Yes or no?
Technically, we are.
Not technically. It's a yes or no answer. Is it closed or isn't it?
It does escape slightly, like a wardrobe has a few holes in it. As you push it, you have a balloon in the middle of it. It will constantly stay in the middle.
So, do we lose matter to space daily or not?
It's only a slight amount, though, isn't it?
So it's open then.
Not like open, like window, like open a little bit of window.
Oh my.
Sorry,
it's not like a convertible. It's an open system, like a window being slightly open in your car.
Right, it's open. Then. If it's open, it's open.
This is not. Let's not bring this into the speculative area. I'm imploring you.
It's definitive by virtue of their own definition. If
Yeah,
we're
well,
in an
but
open
it's
system.
definitive by virtue of a definition, not based on what can be.
Yeah, but it's their definition.
But it's not as black and
Yeah,
white as
I
you're putting it.
understand
It's not as
that,
Yeah,
black.
it is. It is that black and white by your own definition.
It's not.
I think we should go to the bottom of if the pilot is dipping the nose of the plane down as it goes 500 miles away in 1 hour, it should be dipping the nose down a lot, many miles.
I'm just imploring you to think
can-
about this. Hey, Tommy, I'm just trying to get you to think about this because this is actually one of the best ways that you can understand that.
Yeah.
It's one of the most, tangible arguments, one of the most readily.
But the way I see it is like a window open on a train wouldn't have that much of effect on your jump. If you're jumping in a train and the window's open,
Right, but that's a window on a train. So let's put that into context. What's the window on the train in the Earth system?
It's pretty much the same. It only lets a bit of the air out, so it's technically open, but it's not open to the point where it's.
So
gonna
where's the
affect you.
containment then?
Where's the containment?
On the Earth.
Meaning.
Well, if you're going to compare being on the Earth to having an open window on a train, that means 99% of the train's covered by the train. 99% of the Earth's covered by the train. So what's the comparable thing in the Earth system on the heliocentric model to explain why we, basically do what we do as though we're in a closed system?
Once you leave the atmosphere, then you're outside, aren't you? So then that's when
Right.
you have that effect where you travel. That's how like the International Space Station does more rotations over the Earth quicker because it's outside.
Right, so you haven't answered my question. My question's clear. You said it's like opening a window on a train. It's not going to make that much of a difference.
Yeah.
All right. So what's the equivalent on the heliocentric model for the Earth?
I ain't got the numbers for you to give
Not
you.
numbers.
That's just my
Not
assertion.
numbers.
No, it's not numbers. We're talking about the rest of the train.
Gradient of gravity, you could only say.
The question's about the rest of the train.
I'm just trying to give you a view.
Yeah, no, and I'm
of
saying
how
it's nonsense because on your model you don't have the rest of the train to open the window from.
Well, I'd actually use a different analogy to having the window open because the thing
so
is,
does that mean that you disagree with Tommy?
A little bit.
Great. So let's move on then. Tommy's point's now dropped. What's
That's
your
fine,
point,
that's
sir?
fine.
The thing is, I'd use a different analogy. It's more like having
Hello, Crichton.
instead of having
Hello?
a window open.
Hold on a second.
It's
Hello,
more
Crichton.
instead of having a window open.
Hold on. Byron, can you hear us? Okay. Bye-bye. Sorry, carry on.
Okay. So instead of having a window open, because the thing that actually causes Earth to lose matter is actually solar activity from the sun.
Okay, have you got any evidence for that?
I can't provide evidence because I don't understand this.
So we'll just drop
well
that
enough
as an
to-
assertion then, because you're going to make an assertion that the sun does something, then we want to see proof.
Hi, Chocolate.
So if we take the assertion that the sun removes matter from the Earth, then
we're not taking that assumption.
It's a bit like when we said we won't beg the question here and you ignored it and then pissed it right back in our faces 2 or 3 times. So he's just said, unless you can back your assertion with evidence, we're going to ignore your assertion. That's not an indication that you reassert it 3 more times.
I'm not going to reassert it because if we remove that assertion, then we can treat the Earth as a closed system.
No, you can't.
Sorry, what's keeping it closed? What's the lid? If it's a closed system, it's contained. So what's containing us?
The pressure of the atmosphere.
Sorry, pressure doesn't contain us. Yeah, the PSI measures the pressure that it presses on the container. So the pressure isn't the container.
And
Hello?
also, you can't-
What's
you can't have
containing
a-
the pressure? You've said we can consider it a closed system. What's giving us pressure? What's it pressing on?
And Nathan, the other thing is they can't have a just so story to negate the purpose of just to have the purpose so that they don't have to explain how it's not an open or a shut system. It's either one or the other. It's either open or shut.
Oh, it is
You can't have a
absolutely...
just so
No.
story.
They can't have it one way or the other. It is absolutely... Their bullshit heliocentric world is an open system.
Well, can you prove that it's an open system?
Yeah, you go to the...
Rocket
According
went
to
to the
you,
moon.
dickheads, you're going to the bloody moon and Mars, and gas is escaping. It's open, idiot.
Yeah. And there's no walls for a window to exist.
You're going to tell me what the ceiling is that's keeping it closed? Or are you just going to dance around like you've done a couple of times already? He asked you a question. The train, Tommy. You said it's like a train. So
Yes,
what's
it's
the
like a
thing
train.
around you like the
Things
train?
can escape, and there is a way out, and it is technically open, but it's not.
No,
an
there's
open
no way
system.
out.
Not technically, just open. So, we've established it's open. So where are we getting gas pressure from? What's the gas pressing on?
That's the grey area. That's where.
It's not a grey area, dickhead. It's just bullshit. We don't live in space. We're not on a sphere. It's not a bloody grey area. It's our absolute demolition of your religion.
Yeah.
It's not religion. It's not a religion.
You said it's a grey area, and I'm saying no. You can't have gas pressure without a container, but you've got an idea that it's an open, close, close, open system. And then when we pin you down, because you're going to the bloody moon, it's an open system. And then we ask the very pertinent question, how do you have gas pressure without a container? Answer from retard, it's a grey area. No, it's the demolition of your religion.
Or your misunderstanding of what they're saying.
Not a misunderstanding. You can't have gas pressure without a container. PSI. What's it pressing on? The grey area?
Yeah, the grey area.
No, it's not. It's just bullshit, mate. Space isn't real. You can't have gas pressure without a container. You can't have an open-closed system that's a bit open when you want it to be and a bit closed when you want it to be. It's just bullshit.
It's called a just so story.
It's like it's something to do with the sea, and it like when you go deeper down, there's more pressure than the sea at the top.
Yeah,
sorry, is sea a gas? You absolute retard.
The sea's held in by the land, is it
Sorry,
not?
let me just get an answer from this retard. Is the sea a gas?
No, it's a liquid.
Right, so when I said you can't have gas pressure without a container, did you hear the word liquid?
Liquid's the same. Liquid can fall like it's quite.
Sorry,
similar.
did you say liquid's the same?
Well, just the same as that. But
Other than it's got bonds that hold it together, which gas doesn't. Gas is affected by entropy. It disperses. Yeah? You've got a lower pressure. 10 to the minus 11 torr next to gas pressure. That is a violation of the second law of thermodynamics. Silence.
No, I'm sorry, it's because you're just shouting and screaming, isn't it?
Yeah, I'm shouting about your retardation. You can't have a vacuum that is 10 to the minus 11 next to gas pressure. That is absolutely ludicrous and defies the second law of thermodynamics. You can't have gas pressure without a container.
I don't think he gets it, Nath.
No, I know he's a retard. That's why when he says, oh, I'm being bullied. No, you're not. We're showing how stupid you are and then pointing out that you have a mental retardation.
I've got a good idea of where all the pressure comes from. It's the scientists prove R. Did you get that? It's the scientists trying to prove R.
No, the gas cap pressure comes because space-time is bending.
I don't think you got it. Oh, yeah. Yeah, you did.
Well, the pressure comes from gravity.
Oh, really? Have you got any evidence for that?
Excellent. What's your scientific evidence of gravity?
There's the Cavendish experiment.
That's not an experiment. It doesn't have an independent variable, which is gravity, because you can't manipulate and control gravity. It also doesn't have an observed phenomena, because the phenomena itself is conjured within the apparatus. It is not an experiment.
You can change the mass of the lead balls.
Well, your independent variable is your cause. So you're saying mass is the cause, not gravity then, mass.
Mass,
yeah, mass isn't an answer, dick brain. You're telling me that the Cavendish experiment, which it absolutely is not, proves the cause to be gravity. Well, in an experiment, you manipulate the independent variable, your presumed cause, which must be gravity, and it's not. So this experiment, that it isn't, does not prove gravity.
You can manipulate the variables such as mass, right?
That's not gravity. So if you want to prove the cause to be gravity, you need to manipulate gravity as your independent variable.
And we are manipulating mass.
Not gravity then. Hello, are you listening? if you're trying to prove the cause as gravity, then the cause is your independent variable. So can you manipulate this pseudo force of gravity that's been superseded by the bending of space-time? Are you idiot? Yeah? No, you can't.
We can manipulate this force by manipulating the mass.
So you're not manipulating the force. You're manipulating a mass on a contraption. So first and foremost, what is your observed phenomena? The thing that you will make your hypothesis from.
Can you repeat that?
What is your observed phenomena? The dependent variable.
The phenomena that we are observing is how mass attracts mass. We call
really?
this phenomena
So can
gravity.
you tell me, in the natural world, because that's what science studies, where I will observe this happening?
Well, you can observe it happening by doing the Cavendish experiment.
Oh, so like I said, the actual phenomena is conjured within the apparatus. So we're not observing this in the natural world, we're observing it in a man-made experiment. Well, I'll tell you the cause. Man made the experiment, that's the cause.
Technically, you can observe it by dropping something on the ground.
Oh, really? So the Cavendish experiment is to establish the cause of things falling to the ground. It's funny how it doesn't demonstrate anything falling to the ground in the experiment.
Well, we have to... Okay, so we have...
we have to presuppose that the Earth is a sphere, don't we?
No, we don't have to assume that the Earth is a sphere to... we don't have to assume that the Earth is a sphere for the...
Are you sure?
To assume gravity.
Are you sure? Do you want to bring us the mathematics that they extrapolate out from this experiment that's not an experiment because it doesn't have a dependent variable, otherwise known as a phenomena, and it doesn't have an independent variable, the cause being gravity, that you can't manipulate. So it's definitely not an experiment. But do you want to show me how the maths don't assume are? So we can really shove it in your face.
Well, the thing is...
No, just show us the maths that they extrapolate out from this experiment, which is absolutely not scientific, but definitely has some maths attached to it. You want to show us those?
The math...
You're going to show us so we can really humiliate you?
The maths are based on the mass of the...
Earth, by any chance? What a shocker!
So when you are...
We live on the Earth, so obviously we have to go from the Earth, don't we?
Get it. Praise it, brother. Tell him like it is. We've got to assume. You tell him, Tommy. You tell him your religious faith, my brother. We must assume.
I'm so far.
Hallelujah. Gonna assume. Gonna assume. Right, Tommy, you religious zealot.
Amen. Ra.
In R you trust, Tommy. Gravitas Dominus. Spiritus Sanctus Arwin, go in peace, in R you trust.
So in the Cavendish experiment, you don't actually...
It's not an experiment. Stop calling it an experiment.
There are things that you can... I'm trying to work out this experiment.
Yeah, we're still trying to get to the point where you prove gravity. So, unless you're prepared to actually prove gravity.
So the thing is, using the Cavendish experiment, you can...
It's not an experiment. How many times have I got to say it to you? It does not establish cause and effect. It is not based on a formulated scientific hypothesis. It does not have an observed phenomena. It's conjured within the apparatus. And it doesn't have gravity as an independent variable. Please stop calling it an experiment. Don't insult science.
Well, would you... Okay, can you prove... Okay, I'm trying to work out how to word this.
Sounds like you're trying to back out there, though.
I've got a question.
No, I'm not trying to back up.
I've got another question for you. If you wouldn't mind interrupting here, or I can just sit here and wait for you to finish. It's up to you.
We were at the point where this guy was trying to prove that the atmosphere was held by gravity. Now, not only has he not managed to scientifically validate that gravity is even real, we definitely haven't got to the stage where he shows gravity holding gas pressure without a container. So we definitely not going to get to the stage where we're going to get a practical demonstration of gravity holding gas without a container, are we? Because we've got no scientific validity to gravity, and we don't have any experimental data to validate it either, because we don't have an experiment. We've got a parlour trick made by a guy called Cavendish.
So if you look at the Cavendish
parlour trick,
whatever you want, okay, we'll call it the parlour trick if you want. It shows that mass attracts mass.
It doesn't.
Sorry, no, it doesn't. If you want to show that something happens, a cause, which you're attributing gravity to this cause, then you have to scientifically validate it.
Okay, so can you prove that Cavendish doesn't show that mass attracts mass? Because I have seen many things of Cavendish, and each time the mass in that moves towards mass.
I couldn't give a crap. The first thing you do in science is observe a phenomena. You don't set up a man-made device and then decide what that man-made device is causing, because you've made it. That's man-made. That's not a naturally observed phenomena. So can I destroy Cavendish? Yes. It doesn't have an observed phenomena. You're conjuring it within the apparatus. You claim... Oh, you're talking all over me. You claim that mass attracts mass, but where does it actually happen in the natural world?
If I drop an object, right?
Then you've picked it up first. After picking it up. What? The cause of that was you picking it up. You want to know the cause and effect of if you drop something? The cause is you picked it up.
Can we just allow the guy to finish his point without him being interrupted?
Yeah, he said if I drop an object. Well, I'm pointing out that before anything can drop, you first have to pick it up. Before the apple can fall to the ground, it must first grow.
Yes, so...
so there's your cause. There's no need to scientifically validate this. I've just given you a cause. No need for any further experimentation. I've given you a cause. Why did the thing you drop? Because you first picked it up.
That'd be fair, wouldn't it?
That's the cause. Do you understand?
But, okay, how does me picking... What forces is acting on it when I let it go that makes it drop to the ground?
Its mass. It's bigger than the air that it's passing through. How did it get there? The cause was you picked it up.
Yes.
Yeah, had you not done that, it would have remained in equilibrium.
And once I let it go...
you've danced over the bit where you picked it up. So had you have not picked it up, it would have remained in equilibrium.
I agree, but the thing is...
So what are you trying to prove then? So what are you trying to prove? What are you trying to establish a cause from? I've just given it you. You picked it up. There's your cause.
Me picking it up isn't the cause of it falling to the ground.
No, you opening your fingers. No, that would be you opening your fingers.
But once I let it go, it doesn't...
Then its mass is greater than the air that you put it in. So you, by picking it up, suspended it above a medium that was less dense than it. All of these things were caused by you.
But and I can agree that. But once I let it go, then I'm not acting upon it anymore.
Yeah, so what you're saying is once you let it go, you're going to remove yourself from having any influence over it. Oh, that's convenient. So what? So then you can magically attribute a force of gravity to it? No. Every cause is attributed to you. Now that you've dropped it, you're not going to remove yourself from the equation, my friend.
Well, the thing is, I am no longer... when I let it go...
There's the cause. Once you let it go, you let it go. That's why it dropped. You let it go. There's your cause. How many times?
Well, once I've let it go, I am no longer acting upon it.
Yeah, but you've already acted on it. You don't need to anymore. You've already done the dirty deed of picking it up.
Nathan, let me have a minute with this, gent. Let's change the variables here, because we all know about things that drop. Let's talk about something that'll float. If you get a cork and you stick it on the surface of water, it's going to float. Agreed?
Agreed.
Now, if you from the underside, if you're underneath the water, then you pull the cork down and then let go of it, we agree that it's going to go up. Correct?
Correct.
So if gravity is really a thing, why is it not going down?
Because the cork to go down, it's due to mass. If the cork has a It's due to a law called, I think it's Archimedes' principle or something like that.
The cork has air in it, basically.
Called buoyancy.
Well, there's a principle called Archimedes' principle, which means that for an item to sink, it has to displace.
Right.
Or for an item to float, it has to displace as much water as is its.
Yeah, that's our principle on displacement.
Yeah,
and that's not contentious. I agree with you on what that displacement is. Let's apply it. Who's playing a hangout in the background?
Was. He's good. He's got himself on mute now. He'll figure it out. So pretty much the opposite of dropping the banana through the air. We've got the cork going up through the water. So it's buoyancy and displacement and density. Like I said, you just want to ignore all those things because you've picked something up and dropped it, and it goes down relative to where you picked it up from.
Well,
so
hang on. We haven't quite finished yet, Nath. The displacement point. We agree that Archimedes' principle of displacement applies, right?
Yes.
So we agree that the water is more dense than the cork. So when you pull the cork down, the cork appears to, from our perspective, to go up because the water is more dense than the cork, and it displaces the cork to its point of where it's no longer in the disequilibrium. It pushes it back up to its position where it's not in a disequilibrium relative to the water, because that's why it goes up. Do we agree at this point?
We can agree with that.
Right. So where's the gravity in that example?
Well, the gravity is in the... So the cork has a mass, the water has a mass, and what happens is if the cork was able to have a mass which displaces less water than its mass, right? So if it was dense enough to displace less water than its mass, then it would go down.
Yeah, but in this case, it doesn't, does it? So it goes up.
And the simpler way to go about gravity is the way that seeds know which direction to grow from.
Hang on. I want to close on this point. Where's the gravity in the cork explanation, please?
So it's still there. If you look at the formula for buoyancy, it's actually got a value in there called G.
That's right. Same as the value for R when we look at the refraction indicator, right? 76R. And we ask you where the R is. Well, now I'm asking you, where's the G?
Well, we have calculated G using things like the Cavendish experiment.
Not an experiment. Yet again, we get to the point where we've already demolished the Cavendish experiment. It's not scientifically validating gravity, and yet you want to refer to it again. Why would that be?
Hang on. His point was that it was calculated from the Cavendish. But there's an issue on causation on Cavendish, and that's what we're pointing out. So we accept that you can calculate from Cavendish, but we don't accept that you can prove the thing that you're calculating from. In other words, the calculation's invalid. You've got to have something to prove the calculation's valid, otherwise you can't have it. It's making an assertion without evidence, right? So the question is, where's the evidence of the little g that you need for your buoyancy equation?
Well, the thing is that when it comes to Earth, we know that it has a large mass, right? So
no, we don't know that.
Why?
We don't know.
Where have you got that from?
How do we know that?
Well, it's like even a flat Earth must have mass. The Earth, no matter.
Whoa! You keep on saying mass. Can you define that for us?
I'm just trying to work out a good way to just.
I guess what John's asking is, what's the difference between mass and weight?
Well, the difference between mass and weight is.
I didn't ask that question. I asked you what was mass.
Mass is simply something like if I have a phone, its mass is how much it. A good way to describe it would be how much it weighs. But thing is, you can use mass and weight interchangeably.
Really?
You're not defining mass. Define mass, please.
Created from the 92 elements.
Say again?
Well, like, it should just let the guy just run his argument out rather than getting him to go and explain mass, explain everything he's explaining.
No, I didn't ask him to explain it. He kept on saying mass. I want him to simply define it. It's an easy question. What is mass?
He's stopping him from actually getting his question out. Do you know what I mean?
I didn't stop him.
But he is stopping him by asking him to explain mass rather than just let him run with what he's got to say.
Define mass, not explain.
I said define mass. This is easy. Just define it. I didn't interrupt him.
It's essentially it's the amount of so I can weigh something, right? And it comes up as so many kilograms. But if I levitate this thing, it still has that mass of. So if I weigh something and it has 4 kilograms, and then I levitate it so that it's so it doesn't seem to weigh 4 kilograms. Instead, it doesn't come up as anything. It's still got that mass of 4 kilograms. You cannot change.
What the heck are you talking about?
This is the worst definition of mass I've ever heard.
Define mass, please.
Just get a definition up and read it if you're not sure.
Well, if I go to Google and search mass, it says mass is both a property of a physical body and a measure of its resistance to acceleration, a change in state of motion, when a net force is applied. It also determines its strength of its mutual gravitational attraction to other bodies. The basic SI unit of mass is the kilogram.
Right.
So mass is the resistance of a force of a body. Say that. Can you say that one more time, please?
It says it's a measure of its resistance to acceleration.
Okay. So everything that has physicality, because you just described everything, right?
Everything has mass.
Everything is mass, and mass is everything. So if something describes everything, it actually describes nothing. Have you ever heard that before?
Well, here's the thing. It's not describing everything. It's just describing a property of everything.
A property of everything.
Right.
So
I'm struggling here with the definition of mass.
Yeah.
Where are we going with the definition of mass? Let's move on from it.
Can I bring up the point about seeds? When you plant them in the earth, that it's the gravitational pull that
gravitation.
What
gravity? Which gravity are you talking about here?
I think the better way to explain gravity is when you put a seed into the earth, how does it know which way it's to grow up?
Which gravity are you talking about? Newtonian or Cavendish? Or Einsteinian?
Just keeping it simple. Or just gravity, like the pull.
There's 2 different types. There's Einsteinian and Newtonian or Cavendish.
Which one are you talking about? Rather than going into the technicalities of everything. You
claimed gravity. We're not presupposing here. You claimed
this. You did that. Start shouting and going on the hammer, idiot.
I'm not shouting. You claimed gravity. Stop talking. You claimed gravity. Which gravity are you talking about? And then scientifically validate.
Just gravity, mate. Just gravity. Simple as that.
But there's 2 though.
Just gravity. The gravitational pull.
Well, here's the thing.
The gravitational pull. Right? So you're referring to Newtonian, right?
Can we talk about the seed thing that I'm trying to put us towards?
We're trying to work out where we can work out gravity.
So I think I can come up with a good answer. Because Einsteinian gravity, otherwise known as relativity, encapsulates Newtonian gravity.
Encapsulate?
No, it doesn't.
It doesn't.
No, it doesn't, sir. Einsteinian gravity is not a force. Newtonian gravity is a force. So what are you talking about?
When it comes to the mathematics of gravity, then when it comes to the mathematics of gravity, then Einsteinian gravity encapsulates Newtonian.
Encapsulate it doesn't. The wrong word. Einsteinian gravity has replaced Newtonian gravity, not encapsulated it. It replaced it.
Sorry, can we just get some acknowledgement? One is a force, Einsteinian Cavendish gravity. One is not a force. That would be Einsteinian gravity. Can we get some acknowledgement of this? They're not the same.
I'll have to.
I mean, I asked questions, and no one's answered any of the questions of what doesn't make sense to me on a flat Earth or with the gravity situation.
Sorry, you asked us about which way a plant grows, and we said which gravity you're referring to, and you didn't know. You said just gravity.
Ground, any seed that will grow up like a tree, okay? It's under the
We've
ground.
heard this 3 times. We've heard. Then we asked, which gravity is this in reference to? And your answer was just gravity. Now we're pointing out... Shut up! Shut your mouth. Now we're pointing out there's 2. Which one do you want to apply? The one that is a force or the one that is not a force? Because there's 2.
The one that is a force.
Oh, the one that is a force. So that would be Newtonian Cavendish gravity then.
The answer is yes. Say yes.
So what? How does it know which way is up?
No, we're asking you to clarify which gravity. You said the one that is a force. So we're saying. So you're saying the force of gravity we are talking about. Why are you talking over me? Shut your mouth and listen.
Why do you want it to be like narcissistic and get into an argument? I'm asking you a simple question.
No, we are getting clarity. You're very triggered and talking over me while we try and define terms. You're just being very rude because you're triggered again. So we're trying
I'm smiling my head off because I'm asking a simple question, and I knew this behaviour would be your response. Behaviour always goes.
Shut your mouth so we can define terms.
Instead you're going, oh, you don't know this, you don't know that, define this, define that, prove this, prove that. Relax. Just a seed is in the ground. How does it know which way is going on? If it's under the ground, it can't get no light.
We haven't finished the gravity point yet. Let's finish gravity, then we'll talk seeds.
Okay.
This is a point about gravity, though.
That is a gravity because of the gravitational pull. That's how seeds know to go up.
So you don't think that the seeds are reacting to the sunlight?
The ground, so there's no. It can't detect where the sunlight is because it's under the ground. If you bury a seed, it can't get no light.
Red rays of the sunlight penetrate the soil, moron.
No, they don't.
Yeah, they do. They have to.
Down.
We know that sunlight affects the way plants grow. You can put a plant facing the sun and it'll face it. Turn it the opposite way and it's not facing it. 3 days later, it's now facing the sun. We know that the sunlight causes plants to change their behavior.
No sunlight can get to it, and it'll know which way to grow upwards. That's how.
No,
it'll know. Plants don't know anything. They're not sentient.
Because they react to the environment, and the hormone in the seed is pulled down by the gravitational pull, which gives it the
gravity. You're making another assertion about gravity, and if I ask you to prove that gravity causes plants to grow down, have you got any evidence to support it or not?
Why does it ever grow up?
Have you got evidence or not? Because if you haven't, we can drop
research on that. You can research it. It's just some.
It's your claim.
No, you haven't got
your claim.
You ain't got evidence for your flat model, but you keep going on.
It's your claim. We don't have a model. Models are pseudoscience.
Yeah, we don't have an indoctrination. We ask whether or not you can prove yours.
We're not here to prove your claim, sir. Counselor,
I'm asking you. How does it know which way? I'm asking you which way does it go? None of us have been to any like astrophysics or any like this Scientology stuff. This stuff that
pseudoscience.
Right, this field, all these expert areas that we're trying to.
Right, so listen,
we're experts in them, so we can all say that.
We're back to the cork and the water, and we were trying to prove the little g part of the maths. Because remember when I said you can't prove the r bit, and then I said you can't prove the g bit. Well, we still haven't proved the g.
Well, yeah, again, I brought up an argument. Yeah, again, no answer to it, so that's fine.
No, you're not finishing points that have previously been brought to the table.
You're too busy attacking. Oh, what's this? What's that? What's this? Rather than just answering the question.
Moving away from the point in hand.
I'm presenting to you.
No, you're deliberately.
What's that? It's not a conversation.
Stop within a hangout.
We were talking about density and buoyancy, and rather than using a brick falling down, we used an example of cork going up. And we had somebody that brought up mathematics as the explanation. And in the mathematics, he told us that there was a little g value. And then we pointed out that there's an issue with the little g value because we don't believe you can prove it. But you account for it with maths. But no one can prove it. So we're saying, unless you can prove your assertion with evidence, you can't have it.
From what I'm aware, weight is what... Without gravity, it is determined under gravitational pull. Everything's down that. Same as terminal velocity as things drop out of the sky. It's all about the gravitational pull and the effect.
Verbal diarrhea. Which gravity?
Hang on. We've gone with Newtonian.
Yeah, but their scientific
pull determines what
their scientific community doesn't follow.
Sorry. No, I know.
Sorry, guys. Can I just interrupt for 1 second? Sorry to interrupt you guys. Anthony. Sorry.
I'm sorry.
Sorry to interrupt. Can you see what's on my screen?
I can indeed.
Can you see this
Yes,
plant?
I can. Yes, I can. Yeah.
What's it doing?
It's going toward the light.
So it's not going up then?
It's definitely they're going up and then towards the light. They're trying to get the light. But
Sorry,
when they're under the ground,
is this
they don't
one
know where the
here?
light is.
I'll just
ambient
circle
light.
it. I'll just circle it. This one here, is that going up?
Yes, indeed.
It's going up and then towards the light.
Sorry, it looks
Definitely,
like it's going sideways to me, towards the light. So to answer your question,
Seeds that are under the ground are searching for the light, so they can
right,
detect light
there's
through
your
the soil.
answer. Excellent. So we've put that to bed then. So the way they grow, absolutely nothing to do with gravity. They search out the light. Excellent. Glad we put that to bed.
Aware though, if they're under the ground, there's no light they can detect.
Sorry,
so there's
let's
no
just get it
ambient
clear
light.
while
That doesn't mean
you
that the rest of the
rumpus
light
the
spectrum
hangout.
doesn't
Let's
get-
shut you up while I make it absolutely clear. You asked why plants grow the way they do and asserted that it's because of gravity. Now you've conceded quite clearly they grow towards the light.
The moon is fully involved as well.
But there is no light when it's under the
You're
ground.
now
When it's
making
a
a statement
seed.
about the moon. Have you got any evidence that the moon's involved in plant growth?
Like I said, the seed is under the ground. There is no
Hang on.
light under the ground.
Hang on. Have you got any evidence for the assertion that the moon has got anything to do with plant growth?
Yes.
The picture that you showed me is of plants that have already come out. They're on about where the sun is to begin with, and the very beginning is a hormone that is pulled down that is affected by the gravitational pull, which lets the seed know which way to
just
go.
happened here. Somebody made an assertion about the moon. I asked for proof, and you've just obfuscated my point again. Why are we making
to finish that point?
without any evidence and then expecting them to just be like?
I'll accept your moon argument. What were you asking me? Sorry.
No, somebody said the moon has got something to do with plant growth, and I said, "Is there any evidence that moons cause anything to do with plant growth? Have you got evidence for it?" And he said, "Yes."
Yes,
Can I see it, please?
Yes, you can.
Okay.
You can look up how plants grow. Simple.
No, you're the one that's making the claim that moons do something to plants.
Yeah.
Right,
Yes,
so you've got to present some evidence that shows that moons have an effect on plant life.
Yes. Because
Right, do that. Because it's like when you say about gravity being in the maths, little g being in the maths, and we say we don't think it's there. And then you say about radius being to do with the calculation for refraction, and we say we don't think it's there. This is another assertion where you're making an assertion, and it's something to do with moonlight and the growth of plants. And I'm asking, have you got any evidence for that? So it's for you to prove, not for me to prove.
Yes, I'm trying to. I'm not a global investor, so get all of that. But if you measure...
So why say it then? Why is it relevant?
Because the moon is involved as well.
Right.
Great evidence.
Yeah, that's just an assertion of your religious faith.
I'm
So you seem to be making an awful lot of assertions about science that you guys probably don't know that much about, but think that we don't know what you're talking about too, but accept it anyway. And we don't accept it anyway just because you're saying it. We want to see that it's true. So like with the R and like with the G, now we're on to Moonlight because you've made a claim about Moonlight. And it's not even important, but you're making assertions. But assertions are important.
You're barking up the wrong tree.
Seriously. No, I'm not barking up the wrong tree. You're the one that's making assertions, and I'm asking for proof.
He's going to start with cliches now. When are anecdotes coming?
Let me explain. If you let me explain, I am siding with the flat earthers. Yeah, Nathan just said it's to do with the sun, and I added and the moon, because it's commonly known throughout all plant growth happens at night time.
Right. So what's the moon got to do with this now, then, other than the fact that you've made an assertion?
That it helps defeat the argument of gravity. Gravity is supposed to be pulling it down. No, it isn't. It's
Gravity.
Pulling it out.
Gravity. Which gravity?
There is no gravity. Electrostatic gravity is the one I follow. You barking up the wrong tree. You're attacking me like a cobra.
No, you're making claims, and we're trying to hold your feet to the fire so you can support your claims. I can say invisible three-toed gnomes. It doesn't, I could say anything, but I have to support it. So what gravity, and show the scientific experiment validating it. Simple.
I'm saying this to back the assertion there is no gravity.
Right, but you've said an assertion that moonlight affects plant growth.
Yes. Because
so regardless of its context, you've said an assertion. Now, I don't know whether that's true or not, and I'm stupid, and I want you to prove that moonlight does do what you say it does.
Okay, check how plants grow. They do not grow.
No, I'm not checking it. You've made the assertion. You present whatever you accept to be true as evidence that moonlight does something with plants. That's it.
I will find some. Give me 5 minutes.
Okay. In the meantime, back to gravity.
Yeah, so I don't know again if you can see my screen. So this is the, obviously not to scale, but heliocentric representation of the sphere Earth with this guy standing on it. And according to Tommy, the plants grow towards the light and are pulled towards the centre of gravity. So I'd like to know why it is that trees on the equator aren't sprouting out sideways. Why do they still go?
Gravity pulls things towards the center. So
are you sure it's gravity or invisible three-toed gnomes?
I'm pretty sure it's
I'm not sure.
This thing.
This misconception that when you're in Australia, you're walking on the ceiling and every should be like, because it'd take you like over a year to walk around the Earth. It's absolutely massive. Like, I don't think that's where you get.
That's a great story.
Yeah.
How many more stories you got?
How many other stories? I've got quite a few, really. I've got like
I know they're just those stories.
It's just the way that the in the northern hemisphere where you can only see certain stars, and then you can only see the other certain stars, like the seven stars on a globe.
Yeah. So earlier I asked you to look up something called begging the question. So you just used the word hemisphere. So before we've gone anywhere with your example, you're trying to prove that the Earth is a sphere, but you've already got us on a sphere. You used the words hemisphere. See, JLB was also guilty of this recently. He decided to beg the question and say, well, how do the southern stars get explained on a flat plane? I go to the southern hemisphere, and what do you know? Southern pole rotation. So it's an affirming the consequent. It's a formal logical fallacy. If the Earth is a sphere, we will see southern pole rotation. We see southern pole rotation, therefore the Earth is a sphere. It's a formal logical fallacy known as affirming the consequent.
How you like that?
7 stars, and that's going to only be explained yet again on the dome. And I just want to know, like, Nathan, are you like religious? Do you believe in God? And do you believe that the world's designed and it's a flat firmament over our head and
he's not religious, you are.
Yeah,
the stars
you've already pointed this out.
Yeah, believe it's designed.
You've already pointed this out when you brought up a piece of information that you didn't understand but just accepted based on pure faith. You are the religious one.
Or are you going to go on at me again? Because that's typically your constant, like, the way you ask questions.
No, I don't.
Rather than ask a question, you rather attack me again. So ask you again, are you religious? And do you believe it's flat and there's a firmament over our head?
No, I don't believe it's flat. I know it's flat. You have a religious belief. Oh, I'm not allowed to answer. I got 3 seconds, did I?
Sorry about that.
Yeah, so I'm still not allowed to answer on my own show while this wanker talks all over me like he's done the entire show because he's a moron and been demonstrated to be so on multiple occasions. He has to talk continually. It's the last refuge of the losing asshole. That would be you, sir. So I will get to answer your question. Yeah? No, I have no religious belief in a flat Earth. I know it's flat. It's obviously and observably flat. You, on the other hand, have a religious belief based on R. Something you don't even know what it is.
I think what he's asking is, do you have any belief in a god or anything like that?
What the hell's that got to do with anything? We're talking about the shape of the Earth. Who cares whether or not I believe in God when we're talking about the shape of the Earth? My belief in the ethereal is irrelevant when we're talking about reality. So his question is totally inane, totally pointless and irrelevant, especially when he has a religious belief in the topic we are talking about. He has a religious belief based on R. I have no religious belief about the shape of the Earth. It's obviously flat.
Because it looks flat, therefore it is. That's what you're saying.
No, it's obviously and observably flat.
Have the evidence to prove your assertion.
Yeah, again, Nathan hasn't answered the questions that I've proposed to him. Instead,
I have. You asked me if I've got a religious belief, and I've said it on multiple occasions. No, I have no religious belief in the shape of the Earth. It's obviously and observably flat. You, on the other hand, have decided to take the concrete nouns that we see around us at distance and give them the title of phenomena, based on a model, based on R, based on your religious faith in that model.
So you're protecting your religion and accusing me of being religious, which is just absolutely hypocritical.
It's not hypocritical. I don't have any religious beliefs. I look at a building across the way and say, building. That's the end of my explanation. I don't even have to go into an explanation. I just see a building. It's very far away. Why? Because the Earth is obviously and observably flat. It doesn't even need me to say that. I just see a building. Needs zero explanation. You, on the other hand, see a building across the way and say, that's a phenomena. We shouldn't see that. The Earth's in the way. Why? Because you have a religious belief in an R value, in a globe model. That is your religious belief.
Do you believe in a creator?
Jesus,
do you believe the
why
world
are you
is
so
designed?
hot on your mic?
Is that a yes or a no?
Third
Doesn't
time.
want to
I
answer
have
one
no.
question. Narcissistic.
Yeah, I'm trying to answer again and you're talking. No, I don't have a religious belief in the shape of the Earth. You do.
Never asked you that. I asked you if you believe in God or a creator. That was.
Who cares? Who cares if I believe in God or creator? What the hell does that have to do with the shape of the Earth? Absolutely nothing, other than for you to pour scorn on whatever I answer with.
Tommy, why does it matter whether he has a religious view or not?
If his foundation is created, he's not a religion, and I'm quite happy to believe if what makes most sense. And if it's flat, it's flat. It's not a problem to me, but to him, it is a problem if it isn't flat because it attacks his core belief.
No. So what's the answer to my question? Why does it matter if he has a religion or no religion?
Is it behavior?
No, why? No, it doesn't. No, that doesn't matter. Why does it matter?
As I said to you, because it stems from he's actually defending his religious belief, accusing me of defending my religious belief, when really it's the guilt he's accusing. I'm not trying to defend my religious beliefs.
So you're accusing of projection, is that what you're
saying? Yes, that's exactly what's happening here.
No, it's completely the opposite. You are projecting your religious faith onto me. You have a religious faith. When you see something in the distance, you say, I shouldn't see that because there's a model. That would be the thing you worship and believe in, the globe model, based on a presupposition of R. So you have a faith in R, and you will literally defy the thing you see with your own two eyes based on your religious faith. Now, when I look at the same thing, I just say building. No explanation required.
Thing is, we can tell the reason that we see these buildings is because of things like superior mirages and atmospheric refractions.
Oh, so it's not just being seen, like I've just asserted. It's actually a mirage. It's something that's not really there because the model says it's not really there. We can't just see it with our own two eyes. It's actually a mirage. Exactly as I've just said. You are asserting your religious belief. So I just see a building. Shut up! I just see a building because it's there. You see a building, but it's not really there. It's a mirage because your model says it's a mirage because you have a religion.
We can observe that things are mirages. There's actually this person on Twitter. I'm trying to find the exact thing where he shows that miraging is having an effect on how much we can see of these buildings.
And you think these mirages can just bring back a whole building behind a curve?
Yeah. Can I just point out, Nathan, that we've not had closure on the gravity point, or on the radius point, or on the moonlight point,
or on the pressure, or on the pressure without a container point, which is why we were on gravity in the first place.
Can I take it last first and do the moonlight?
Are you going to prove that moonlight has an effect on plants?
I've got papers, 2 garden sites, all backing up my assertion, yes.
Right, present your screen and let's see what you got, and let's see if it's credible, and let's see what point it makes.
Let's see.
Now, let's go with the idea that he's about to prove a point. Gents, this is what you need to do to prove a point. If he's going to cite paperwork of something to prove something, this is what you need to do.
I think that's it. Anyone see the screen?
We can.
Okay. So we have. And bearing in mind, I am not a globe. So any mentions of gravity is the cause, I do not believe that. All I believe is that, or all I'm looking to prove is that the moon has an effect on plants.
Okay.
So, Journal of Plant Studies, published paper, published by the Canadian Centre of Science and Education, 2013, accepted 2014. In the interest of moon-related fluctuations in tree biology and physiology, has been revised by recent experimental research, which could confirm the existence of real phenomena. In this context, previously published extensive data from germination tests from the European spruce using established standards. Either way, this is a paper on exactly what I was talking about. If I go to conclusion, and obviously they gravity gets involved, but the point I was making.
Right now, what I want you to point out is somewhere in this document where it states that moonlight caused this effect, whatever effect it was. Find something that proves causation and why it says it. That's what we need. So I'm applauding you for bringing something. Now I want to see the part where it proves or says. There you go in the conclusion.
Yeah, be it tested with the help of orthogonal contrast C1 to C3, which I'll give you papers either way if you need. In the germination process of spruce in particular, receives, oh no, sorry, it was the top bit, tested with the help of orthogonal contrast C1 to C3, or with the help of contrast to C4 alone, which corresponds directly to sowing. Both statistical weights demonstrate a significant relevance of the factor of moon phase.
Right. So now you've presented some evidence that proves a point. Now, my question is, we can accept based on this evidence that there is probably an effect with moonlight on plants.
Yes,
so let's put it back to the other two drongos who make the claim about gravity and radius. Is there any evidence of gravity or radius that you gents can produce that helps prove your case, like this gent's just done? Because now we can say that it appears that moonlight does cause plants to do stuff.
I have this site here from Science ABC, and it says, okay, let me see where it, okay, so it says, how do seeds figure out the effect of gravity and grow in the right direction? Short answer, seeds can sense gravity and position themselves in accordance with it. This behavior is dictated by a physical phenomenon called gravitropism.
Can we see this on screen, please?
Yep.
Can we see this on screen, please?
Which gravity?
Yeah, I'll just...
I unshared, yeah?
No, the guy speaking now, planar. Yeah, that's it. Let's see.
Yeah.
So we want to know what the citation is first. Where's it from?
It's from scienceabc.com.
And who's written this article? Just scroll back up to the top.
Ashish. I'm not sure if that's...
So you're going to cite an article from Hashish. Okay. So come on then, let's see the point where it makes.
So it says roots grow in accordance... Yeah, roots grow in the direction of the gravitational pull, whereas stems grow in the opposite direction. And it says, let's start with the basics. What is gravitropism? Gravitropism is simply a plant's or fungus's growth movement in response to gravity, also referred to as geotropism. It is commonly observed in most plants and other organisms. The roots of a plant show positive gravitropism as they grow towards the gravitational pull, while the stem displays negative gravitropism as it shoots upwards away from the gravitational pull. Given
that's amazing. That's amazing. Okay, what's the... Yeah, it is a lovely story. Okay, what was the natural phenomena observed, please?
Yeah, because what we want to see is how did they prove this gravitropism?
Well, it says here, given below is a picture that clearly depicts a phenomenon.
That looks like a concrete noun to me. That looks like roots have grown through the top of an archway on a bridge. So what? Where's the phenomena?
Well, it's growing downwards.
So you're saying the naturally observed
phenomena still not a phenomena?
No, hold on. Tree roots grow downwards. That's the phenomena, would you say?
Yes.
Okay. Do you know downward? Right. Do you know what downward is as a term?
Well, I'm using it as a term you know, if you've got something and it falls, that's the direction it falls in will be down.
What is down though? What is down as a descriptive thing? What is down?
Well, it depends on what model you use. You know,
so it depends. So it depends is another way of saying it's relative, right?
Yeah.
So you're going to look at a relative direction as an observed phenomena. Is that correct?
Yes.
And I would add to that I don't think this even satisfies the definition of a phenomenon. It looks more like a concrete noun. I don't see.
Not in a model, but in real world. What is down? Just in the real world.
Well, all I see is what looks like roots that have grown through a bridge.
All right, hold on a second. Hey, Nathan, let's go ahead and allow him his observed phenomenon here. Let's go through the steps. Let's see what he comes up with. You want to share my screen?
Yeah, we'll do this and then we'll round out. I think
you want to share my screen, Nathan?
Yeah, I've shared your screen. If you want to, we'll go through it step by step and then we'll round out the show on this note, I think.
Okay.
You're on.
Tell me when it's up.
Yeah,
You're up.
Oh, I'm sorry. I got the last catastrophe still in here.
Just as you're letting someone talk, you're going to end the show. It's fast. That's interesting.
Well, he's an hour over anyway. It should have finished at 4 p.m.
Yeah, I lost track of
time.
It
has been good, and honestly, I've enjoyed it. And you know,
thank you.
For allowing us to
Tree grow upside down, right?
Tree roots grow down. Tree roots grow down. Well, I don't want to do it for you. I don't want to. You put it in your words, if you will. Is it gleam?
I'm just asking him if that's the observed phenomenon.
Sorry,
the tree roots grow downwards.
Tree roots grow downwards?
Yes.
Sorry, it's a little slow. Yeah, punk. Okay, what's the hypothesis?
Well, the
hypothesis is that it's due to gravitropism. So it's being affected by gravity, and so the plants detect the gravity and then grow in accordance to it.
Tree roots grow downward due to gravitropism. Is that what you said?
Yeah.
Okay, what's your independent variable?
The independent variable would be it's a good question. Let me have a look at. So, okay, here we go. Thomas Andrew Knight demonstrated gravitropism with an interesting experiment. It says here, plants have been growing the same way since the dawn of civilization, and man has always been intrigued by their behavior. Around 2 centuries ago, a botanist and horticulturist named Thomas Andrew Knight proved gravitropism with a rather fascinating experiment. He said, if you have ever taken a ride in a spinning teacup in an amusement park, you know all too well that you get pushed away from the center of the spinning object.
Can we have the independent variable, please?
I'm just trying to...
It comes from within this. I'll give you a clue.
Okay. It says here that it turned out that plants responded to gravity pretty much the same way that humans do. It was...
I think I didn't... I don't think you...
Gravitropism.
Wait a second. I don't think you understand what I just said. Your independent variable is within this statement. Yep. Which is it? Tree roots grow downward due to gravitropism. Which one?
It would be gravitropism.
Excellent.
Because we worked out how to manipulate it.
Excellent.
Okay. So gravitropism causes tree roots to grow downwards. That's it?
Yeah. Yes.
Okay. What's gravitropism?
Gravitropism is...
You have to physically manipulate this as an independent variable.
Yes. So if you spin... So if you have a seed, right, in some dirt, and you spin this dirt so if you have it spinning, it detects what it thinks is that the gravity is now in the towards the outside of the spinning object.
Yeah, I'm not talking about that. I'm saying, how can you physically manipulate gravitropism? What is gravitropism? Is it physical? Does it have chemical formula, structure, charge, mass, momentum, or spin? Or millielectron volts, kcals, or kilojoules?
I don't know what the unit for gravitropism is, but it says in this thing that if you put a seed in dirt, right, and you spin and you have it in this, just say you have it in a bucket, right, and you've got this bucket spinning, and it's near the outside of the bucket, the roots will grow towards the outside of the bucket, whereas the stem will grow towards the inside of the bucket. That is how we manipulate gravitropism, because it thinks...
That's manipulating gravitropism.
That's spinning.
That's identifying it. How are you going to manipulate it?
Well, we are manipulating the gravitropism in the plant by spinning it.
Well, no, that would
You're
be
spinning.
No, you're applying a centrifugal force.
That's
Wait a second. He's spinning the gravitropism. What is gravitropism?
It's the thing in the plant which allows it to detect which way gravity is.
Okay. Do you have a picture of it? It has to be something the researcher physically manipulates. So what is it? Do you got a picture of it?
Okay. Instead of saying that the cause is gravitropism, let's say that the cause is what the plant thinks is the direction in which the plant thinks gravity is pointing.
Sorry, plants
don't think.
Well, the way in which the plant identifies gravity to be pointing.
How can it identify? Plants are not sentient or intelligent. They're not identifying anything.
You can still, even though something isn't sentient, it can still identify certain things, like bacteria.
Oh, it can.
Bacteriums can identify that something is food because it's inbuilt into it, it can identify that something will give it nutrients because.
Sorry, I've got to stop you. Sorry, I've got to stop you there. So this was what Tommy did when we had him over a barrel. He went on to a completely different topic. So at the moment, you're claiming gravitropism, and we are trying to establish scientific validity. We're not at the experimental stage yet. We're at the hypothesis stage, and you're failing flat on your face, because the thing you're trying to prove is your cause is gravitropism, and it's been pointed out that you can't show it us. You can't give us something to manipulate.
The gravitropism is the mechanism by which, the gravitropism is the mechanism by which the plants identify the direction of gravity.
Yeah, we're trying to establish that through systematic experimentation, i.e. science. And the first thing we would do to establish that would be to formulate a hypothesis, which is what John is trying to take you through right now.
Yes.
Right. Well, the problem we're up against is the very thing that you're trying to prove exists is the thing you're claiming is your independent variable, even though you haven't shown it to exist. So how are we going to vary and manipulate this independent variable?
Well, we do this by spinning this bucket. By spinning this bucket, we know that the plant has identified the direction in which it should grow, because it thinks, okay, this way is the direction in which gravity is pointing.
So your independent variable is spinning bucket.
Yeah.
Right. So your cause, sir, in this cause and effect relationship, without doing any experimentation, just based on your hypothesis, according to you, the cause in this cause and effect relationship is spinning bucket, not gravito, whatever the hell you think it is.
Gravitropism is a mechanism.
You see, this is the non sequitur tautology test, and this didn't pass, sir, because you have spinning bucket causes tree roots to grow downwards.
Well, in this case, it would be the.
That's breaking it. That's breaking it down into a way that's not what it's saying. That's not the full story. There's a lot of variables into that would accumulate to the answer you're looking for.
A lot of variables.
So a complex
excuse me.
hypothesis.
Sorry, excuse me. Did you just say a lot of variables?
What I'm thinking is, if it's a spinning bucket, then it's obviously trying to counteract the gravitational fall. And if it's still growing the same way, that's why they're saying, well, it's obviously the gravity's causing it.
Did you hear my question?
That's my assumption.
Did you hear my question? Did you say a lot of variables?
Nathan, rather than going narcissistic and start to go onto me,
no, stop
picking at little things and being really like petty.
Tommy,
chill.
stop being an idiot. Answer his question.
What's his question?
Try and repeat it.
You never answers any of my questions, by the way. So,
sorry,
you know,
try and
let's
repeat
put
it
that
back to me. Let's see if you pass the intelligence test of being able to listen to somebody.
Answer any of my questions. You've not gone. All you've done is.
Let's see if he passes this intelligence test while he talks non-stop. I'll stick him on mute. Let's see if he can pass the intelligence test. What was the question I asked you?
Whether you was religious or not, and whether you believe God is on the whole place, and yet you wouldn't answer that.
God.
No, that was a question you asked me. So you failed this intelligence test miserably. I have asked you to repeat the question I asked 3 times to you, literally within the last 60 seconds, and you can't do it. That is how stupid you are. We are literally dealing with the dregs of society in terms of intelligence. You are, quite literally, thick. That's what you are.
My word! He's rumpusing. He's killing us in here. Now, can we get back to the hypothesis? This is just a simple diversion, right? Let's get back to the hypothesis, because this is a train wreck. Now we got spinning bucket, right, as your independent variable. Where is the spinning bucket up here in your hypothesis?
Okay, I'm just trying to work out the best way to describe this, because it's 4 a.m. where I am. So
okay.
The independent variable should be described as something like
the independent variable should be described as gravitropism, because that's what you say is causing the roots to grow downwards.
Well, I'm trying to think of the value that we use, because
according to your hypothesis, this statement right here, due to gravitropism must be it's just that simple.
Yeah, I get what you're saying. The thing that would actually be applied here, because gravitropism is the mechanism by which it detects gravity, right? So we can't physically adjust gravity, but we can't physically manipulate it. So by definition, this independent variable is invalid. Correct. But we can manipulate the direction which it thinks gravity is pointing.
Direction is not an independent variable.
How are you going to do that?
Sorry,
you just said you couldn't manipulate gravity, so how are you going to manipulate the direction of the gravity that you can't manipulate?
We can manipulate the way in which it detects gravity to be pointing.
What? I'll tell you what. One second. You said this is the alternative hypothesis. What is the null? That's what I'm interested in.
This is what I was
What would be the null hypothesis?
So what's the null?
Say again.
Let's get this train wreck.
The null hypothesis would be that tree roots would grow downwards regardless of which way gravity would be detected.
Not exactly a mirror, is it?
It's not a mirror. I'm trying to.
Tree roots do not grow downward due to gravitropism.
Due to spinning bucket. Due to spinning bucket. Let's get it right.
No, but it's
no. Tree roots will not grow down. Yep, that's right. Anthony's correct. But he's been paying attention.
Well, the null hypothesis would be that tree roots would grow downwards regardless.
No, it wouldn't.
No. It's the opposite. So you're saying
the null
downwards.
The null is yep. The null is will or will.
I don't get what you're like. Why is it would not? I'm just trying to explain that it would. If the null hypothesis would be that tree roots would grow downwards regardless of the way that it detects gravity.
Oh, right. Well, how are you going to manipulate that?
Well, you manipulate it by a spinning bucket.
No. How are you going to manipulate the gravity? The thing you're claiming is the cause is the thing you vary and manipulate to show that it's the cause through experimentation. Now you're saying the cause, we'll forget that, and we'll introduce this new thing, spinning bucket. Right?
So the cause is not actually gravity itself. It's
excellent. That's the statement I will end on. Thank you very much. The cause is not gravity itself. Beautiful. With that, I will say, first and foremost, a huge, massive, enormous thank you to all of the debating panel for making this debate possible, and of course a massive thank you to all of the live audience for tuning in and hopefully sharing this debate. If you hated the show, then you know exactly what to do, but if you liked it, maybe consider sharing it with a friend, or subscribing if you've not done so already. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!